All right, welcome back everyone to Anatomy and Physiology. This is Thursday's lesson. We're going to start talking about external respiration, gas transport, and internal respiration. So external respiration is the exchange of gases between the alveoli and the blood. And internal respiration is the gas exchange process that occurs between the systemic capillaries and the tissue cells. All gas exchanges are made according to the laws of diffusion. So movement occurs toward the area of lower concentration of the diffusing substance, so high to low. And this is kind of a blurry picture here. It's not a good picture, so we'll move on. Okay, so during external respiration, dark red blood flowing through the pulmonary circuit is transformed into the scarlet river that is returned to the heart for distribution to the systemic circuit. Remember, systemic goes to your body, right? That's the blood that's going to your body. Pulmonary circuit is the one that's going to your lungs to get reoxygenated. So, and the reason why it changes colors is because it's picking up oxygen. So the color change is due to oxygen picked up by hemoglobin in the lungs and carbon dioxide being unloaded from the blood. So both of these two things are happening. We're having oxygen coming in and carbon dioxide going out. Because body cells continually remove oxygen from blood, there's always more oxygen in the alveoli than in the blood. Oxygen tends to move from the air of the alveoli through the respiratory membrane into the more oxygen-poor blood of the pulmonary capillaries. As tissue cells remove oxygen from the blood in the systemic circulation, they release carbon dioxide into the blood. Because the concentration of carbon dioxide is higher in the pulmonary capillaries than in the alveolar air, it will move from the blood into the alveoli and be flushed out of the lungs during expiration. Blood draining from the lungs into the pulmonary veins is rich in oxygen and poor in carbon dioxide and is ready to be pumped to the systemic circulation. So, oxygen going in, carbon dioxide going out. Oxygen is transported in the blood in two ways. So most attached to hemoglobin inside the red blood cells, but a very small amount is carried dissolved in the plasma. Most carbon dioxide is transported in plasma as the bicarbonate ion, which plays an important role in the blood buffer system. So a small amount is carried inside the red blood cells bound to hemoglobin. The carbon dioxide binds to hemoglobin at a different site than oxygen does. Before carbon dioxide can diffuse out of the blood into the alveoli, it must first be released from its bicarbonate ion form. So bicarbonate ions must enter the red blood cells, where they combine with hydrogen ions to form carbonic acid. Carbonic acid splits to form water and carbon dioxide, and then carbon dioxide diffuses from the blood and enters the alveoli. Inadequate oxygen delivery to body tissues is called hypoxia. This may be something you've heard of before. So it's easy to identify in fair-skinned people because their skin and mucosa take on a bluish cast, so they become like cyanotic. In dark-skinned individuals, this color change can only be observed in the mucosa and in their nail beds. So hypoxia can be the result of anemia, pulmonary disease, or impaired or blocked blood circulation. So here's a couple pictures. So external respiration in the lungs. We have oxygen going from the alveoli to the pulmonary capillary. And red blood cells pick it up, and carbon dioxide is unloading to the alveoli. Internal respiration, oxygen is unloaded and carbon dioxide is loaded into the blood. So so I forgot to mention this. For external respiration, this is the pulmonary gas exchange. So this is when your blood is becoming oxygenated in the lungs. And this is the systemic capillary gas exchange. This is when the blood is circulating through your body, oxygen's being unloaded, and you're getting carbon dioxide. And then we know that blood then goes back to the lungs to get reoxygenated. Carbon monoxide poisoning represents a unique type of hypoxia. Most of you, I think it's a law that everyone has to have a carbon monoxide indicator thing in their house that will go off if it senses carbon monoxide, because it's odorless and colorless, and it will kill you if you don't recognize it. Obviously, I've heard of people who, and this is probably more common in the Midwest where it's colder, people will turn on their car in their garage to get it to heat up and keep the garage doors closed, and the car produces carbon monoxide and it builds up inside the garage in this enclosed area, and it ends up killing the person in the car. Very sad. That can also happen in blizzards. If you get stuck in a blizzard and your car is stuck, and they tell you, at least in the Midwest, they tell you to clear the snow from the I'm blanking out on those words, but the exhaust. So they tell you to clear the snow from the exhaust so you don't get carbon monoxide poisoning. And that's because it's odorless, colorless, you can't recognize it, and it binds on the same binding site that oxygen does on hemoglobin. But hemoglobin actually binds to carbon monoxide more readily than oxygen. So this carbon monoxide crowds out or displaces oxygen. And this is also the leading cause of death from fire. And it kills its victims softly and quietly. It doesn't produce the characteristic signs of hypoxia, which is cyanosis and respiratory distress. What ends up happening is the victim becomes confused and has a throbbing headache, and in rare cases, the skin becomes cherry red. People with carbon monoxide poisoning are given 100% oxygen until the carbon monoxide has been cleared from the body. Internal respiration, the exchange of gases that takes place between the blood and the tissue cells, is the opposite of what occurs in the lungs. So oxygen is unloaded and carbon dioxide is loaded. Okay, sorry, I had to plug in my computer because it was about to die. So oxygen is unloaded, and because we're using the oxygen, your body's using the oxygen. And carbon dioxide is loaded. In the blood, it combines with water to form carbonic acid, which released the bicarbonate ions. Most conversion of carbon dioxide to bicarbonate ions actually occurs in the red blood cells, where there's an enzyme in there that speeds up the reaction. The bicarbonate ions diffuse out into plasma where they are transported. And then oxygen is released from hemoglobin, and the oxygen diffused quickly out of the blood to enter the tissue cells. As a result, venous blood in the systemic circulation is much poorer in oxygen and richer in carbon dioxide than blood leaving the lungs. All right, here's a couple questions. What type of cellular transport moves respiratory gases, between the blood and the body's cells? This is actually diffusion. What is the major form in which carbon dioxide is transported in the blood? This is as a bicarbonate ion. And what is cyanosis? Hopefully you guys remember what this is when we were talking about the skin. So cyanosis is a bluish cast to the skin and nails due to inadequate oxygenation of the blood. All right, that's all we're going to cover today, and that's it for this week. You do have a quiz tomorrow, so make sure you're studying for that.